Hey everyone, today we're making a short video on how to get started with the FRC 2021 starter pack for Unity. We're going to build a very simple chassis, connect it to some robot code so we can drive it around. The idea is to show you how easy it is to get started, really sort of take some of the mystery out of it all and maybe some of the intimidation factor. So you can see here, this is what you see on the screen is what we're gonna build. It's going to take a little while, so find a comfortable spot and watch the video, and ideally, play along on your computer and do this as we go. Now, in the link to the video, I'm going to include a link to this project on GitHub. All right, and this is where the starter project is. And what I'd like to go over is there's a few things you need to have set up at first. Okay. I want you to have the recent version of Unity downloaded. I'm using 2020.2.1F1. I've installed that, and I'm assuming you've got some, rough idea of how to use Unity. There's some great tutorials online. Recommend you go through those. Also need you to have the WPI Lib tools for the 2021 season downloaded and installed and ready to go. Download this particular project, all right, this starter project here. All right, just you can either clone it or download the zip and unpack it. How you do it is all up to you. There's no requirements there. The other thing, we're going to use an example from the Cross the Road folks. They have some examples on using some of their devices, so we're going to download these examples and use their differential drive example, which takes advantage of the Talon SRX. And then finally, you're also going to need the latest release of their code. You can get it at this link here. It's the 5.19.4.1, at least at the time I made this video. The rest of this document sort of lays out the steps, and you can track along with this if you want, but I go through everything in the video. This is just sort of a handy reference for you. Okay, let's get started. Okay, first thing we're going to do is we're going to download the starter project. So I'm just going to download a zip file of it here. Now I'm using a Linux computer, but this ought to be pretty similar on a Windows or a Mac computer. You're going to download it, and it's going to you'll find it in your downloads folder or wherever it goes on your computer, and we're going to find that, and we're going to unpack it. Okay, now the download is complete. We're going to find our download, and we're going to extract it, and you put it wherever you like, but here's our project. So next thing is to get into bring it into Unity. So let's start up our Unity hub. Again, if you're using a different kind of computer, this may be through a different menu, but we need to start up Unity hub. So we're going to click add, and we're going to browse to where our project is. So I just left it over in downloads, but you probably want to put it someplace a little bit better than that. And we find it, and we say OK, and here it is. Okay, so then we click on it to open it up. Now, I've had problems occasionally where it comes up and it says this uses custom layouts and so forth, and it looks like an error. If that happens to you, just cancel and try again, and it should open up. I've never had a problem with it happening more than once. I think there's something peculiar with this version of Unity, but it hasn't really been a problem. So let's get started. Okay, now that we have our starter project open, let's just take a quick look around to see what's in here. So down in the project panel, we've got a number of different assets that come with the project. There's some of the 2021 game pieces. You've got the let's see, the floor of the arena and the walls around it. You've got the if you look closely here, you can see the wall at the end where you shoot your power cells, and we've got a power cell kind of object. More importantly, there's this folder here called FRC simulation, which has a number of different assets in it. So there's a folder full of components that we can use for our drive system, some random set of materials that I've made since I've started working on this. our WebSocket implementation we use. When you do pneumatics, there's some pneumatic components. We're not gonna touch anything on that today. Different sensors. Right now, I've just got an encoder in here. I'll do another video soon about how to do an ultrasonic sensor. It's a good demo one. And then we get some user interface components. We get the driver station canvas that you'll see when you run. The interface to the game controller. We're using a Logitech F310 game controller here. And then at the heart of everything is this RoboRio component, or RoboRio set of data. So there's a prefab for our RoboRio, but then we've got definitions, the scripts for all of the standard I/O types that go with the RoboRio, all implemented with WebSocket interfaces. Now, good news is you won't have to do really any programming in Unity for this demo today. It's really just drag and drop operation to build our robot, and the only coding we'll do would be a small amount on the example code that we're getting from CTRE. Okay, let's dig in. Now we've gone through the assets, the hierarchy up here. I've got, again, some basic starter stuff. I've got a sample of the arena. Let's zoom out a little bit. You can see what we have here. So there's your 2021 arena, minus a lot of things, minus the shield generator and the number of other elements. We don't need those for today, but I hope to add them in the future. We've got our driver station canvas. You can't see it here, but if we go to the game view and go to display 1, you can see I've got a very, very simple set of buttons here that we can use once we're running the code to enable our bot, put it in teleop or autonomous mode or testing mode and so forth. Simulation components. The only one we've got in here right now is just the interface to the game controller, and we've mapped the axes we've set up in the input manager, which if you took the whole project down, the input manager is already set up for you with these. So we've got the axes that we're going to use, and we've also mapped in some of the buttons. The event system is required by Unity when you're going to have user interface components. And finally, we've got an instance of our RoboRio. So we basically used our prefab from down here and dragged it into the project, and we get all of these ports, and most of it's fleshed out. I've got one DIO port for every port that the Rio supports. I've got same thing with analog ins and outs, solenoid ports, PWMs. The only one I haven't really fleshed out are pneumatic control modules, just because there's a variable number of those, and it's a big number, so I didn't want to overstuff the model, but you can add what you need. I do have a sample set of solenoid ports here for most likely the one you'll use, PCM0, ports 0 through 3. Now, let's start building our robot. Our robot's going to be very simple, primitive really, but the idea here is to show you what's possible. Again, I'll have more videos that talk about how you might make it look a little prettier, more like your robot, even using some of your CAD. So let's go back to the scene menu here so we can see what we're doing. And the first thing we want to do is we want to create a game object that's going to be the root of our robot. So let's come over here and we'll create empty, and let's just give it the name My Robot. Okay, so now we've got the root of our robot. And let's create another game object inside here. So I'll create an empty object and we'll call this the chassis. And then inside that, let's create another one called drive system. So there we have some of the hierarchy that we're going to need. All right, first thing we want to do is our robot, we want to make sure it obeys the rules of physics and ties into the physics system in Unity. So what we have to do is we have to add a rigid body to our robot. So over here, we've selected our robot. Over here, we're going to add component, and we're going to type in rigid body, right, ridge, and we've added a rigid body. Now, our robot is most likely going to be more than 1 kilogram. So let's put in something like, I don't know, 25 kilograms for now. It's just the chassis. Now this number here, should approximate what your robot is going to weigh. Remember, this number is in kilograms, so you're going to have to do the conversion. Now, to have the base for our robot, we need something that's going to sort of fill in for the robot body itself. So let's go over here to chassis, and let's add a very simple cube. Okay, that's really easy. Oh yeah, one thing I forgot to do. Let's make sure our robot is at 0, 0, 0. So let's go back and change our coordinates on our robot to 0, 0, 0. All right, and now we can play with this cube. So, probably the easiest thing to do is just pick a size. So let's do 32 inches by 32 inches by 32 or by 4 inches high. So everything in Unity is metric by default. So to make this 32 inches, I've got to enter it in meters. So 32 inches is 0.8128. All right, so we do that along the x direction. We do that along the z direction. X and z form the plane of the ground. So 0.8128, and then let's change the height to 4 inches, which is 0.1016. Now we've got our chassis here, which is, as you can see, 32 by 32 by 4 inches high. Now let's put that close to the ground, or close to the floor. So let's give it a Y position of, let's go with, let's see, our wheels are 6 inches. Let's say we wanted an inch off the ground, so let's do 4 inches off the ground. So how's that work? 0.1016 for our Y position, and you can see we're pretty low to the ground here, but that's fine. That's just what we want. Okay, now it's time to add some wheels to our robot. So let's come over here to our drive system and right click and add an empty object. And let's call this one wheels. Now, to make things really easy, if we look down here in drive system component, I've already got a sort of a stock wheel, or a couple of them. What we're going to use today is the 6-inch high grip wheel. So let's go ahead and take one of these and drag it right into this wheels item. And now we have a wheel for our robot. Now, we want to make sure that this wheel is located in the right spot, and I think the one that's in there is right for what we're doing. Let's see, we want it to be positioned in the robot in the middle. All right, so that means a Z position of 0, which we have. All right, these are 6-inch wheels, so we want it offset the center of it, offset 3 inches up off the ground, and that's what 0.0762 is. And the X position, we want that about 17 inches from the center of the bot. Remember, it's a 32-inch wide bot, right? So 16 would put it, right in the middle of the edge. So we want it out just a little bit. And I think 0.4318 meters is about 17 inches. So I think we're in good shape. I've got these parameters, already set for you here, so don't worry about that. So we've added our first wheel. Now we want to do the same thing, but we need to do the rest of the wheels on the right hand side, and then we'll do the left hand side. So let's rename this wheel here to be our RM underscore wheel for right middle wheel. Okay, you can call it whatever you want, to be honest with you, but this is just the convention I'm using for now. So let's Control C, V, copy paste it. All right, now we've got another wheel. Okay, and let's call this right front wheel. Okay, now it's right there on top of the other one. As you can see, if I move it over, it's right on top, hiding the other. So you couldn't see it, but what we want to do is we want to put it up toward the front of our bot. Now, bot's, again, it's 16 inches to the very front edge here, so we need it back a little bit. So let's say we'll set Z to about 14 inches, right? So in meters, that's 0.3556. And there we go. It's right in the front of the robot. And like the rear wheel, just about as easy. Copy, paste. All right, let's rename it to right rear wheel, or RR wheel. All right, and we want this one equally distant in the back, so we'll just negate the Z position, right? Because our robot is centered at the origin 0, 0, 0. Well, on X and Z it is anyway. I guess Y is shifted up. But so now we've got our 3 right-hand side wheels. Now to make them for the left side, so let's copy and paste the middle wheel again, and I'm going to rename this to be, instead of RM wheel, it's going to be LM wheel. And I want it to be on the other side of the robot, which means I, this time, negate the x-axis. There it is over there. Now, one thing we want to do is we want to turn that wheel around. All right, visually it's going to look the same, but it's going to be rotated 180 degrees around the y-axis. All right, the reason for that is when we drive it, you know, the way Unity works, we want to drive it in a certain direction. It needs to be flipped around, because really the motors on that side are going to turn they're going to be oriented a different direction than the motors on the right side. So we're just doing this to compensate for that. Now we just repeat the steps that we did for the similar to what we did for the front and rear wheels on the right-hand side. Let's do copy, paste. All right, rename. If you don't know, F2, you know, allows you to edit the name of the item. So we'll do this LF wheel. All right. Okay, and we will put that 14 inches off the front, so 0.3556. All right, and then copy paste again, edit the name of it. All right, and this will be LR wheel, left rear wheel, and we'll negate the Z axis, or the Z position rather. And there we have it. So if we step back and look now, we've got 6 wheels on our robot, 3 on the right, 3 on the left. Now, you know, that's what we're going to do for this exercise, but, you know, if you want to play around with it afterwards, you know, add 4 wheels to each side, you know, you can do that exercise. 2 wheels on each side. It's all just about as easy, same as this. Now, something important to add to our wheels so that we can actually drive the robot with some degree of control is we need to put some encoders in here. So if we look down here in Drive System Components, so we have it's down here in Sensors. Okay, so what we're going to do is I've got an encoder prefab, and let's just drag one of those right up into Wheels. Okay, so add it to that Wheels game object here, and let's rename this to be right encoder. Okay, now over here in the inspector, what it requires, the main thing it requires is a wheel that it's going to be attached to. Okay, so we put this on the right hand side. Let's just drag the right middle wheel into that. I told you guys there was going to be no coding here, so I'll just drag and drop. Now, if we're going to wire that encoder right into the RoboRio, I would drag in an encoder port, you know, from our RoboRio object. But this is going to be wired into the Talon, so there's no need to do that. Now, we can make a copy of this guy if you like, or you can drag a new one in there, whatever you think is the most efficient way for you to edit it. But let's add one for the left-hand side. Left encoder. All right, and I need to attach it to the left wheel though, so I need to take the left middle wheel and bring it over here and drop it in, and now it's attached to the left wheel. And I've got this preset to 4096 counts per revolution. This value here, the 0 RPM tolerance. The physics in Unity has a little bit of jitter when you're not moving. So you'll see the robot maybe vibrate a little bit or something. So we've just put a tolerance value in here saying if the RPMs are less than 0.01, we're going to assume we're not really moving. So we want to filter out that little bit of minute movement that Unity puts in there for us indirectly. That's all that is. And then these counts and RPMs, they're not values that we really need to fill in. They're values that are published by the encoder as the robot's running, so you can see what the counts and the RPMs look like, as you're driving around, if you're trying to understand what's going on, see how it works, do a little debug, so you can use those values. But setting them, they'll just be overwritten at runtime, so don't worry about it. All right, so we're making great progress. Time to add some motors to our robot, motors and motor controllers. So let's come over here, back to Drive System, right-click on Drive System, and create an empty object, and let's call this motors. All right. Now, again with the Drive System components, I've got right now I've got a sim motor in here, okay, that I've put together. We're going to use that for today. I hope to add more advanced motors like Falcon 500s and other things soon. This is a tremendously simple little implementation here, just to show what's possible. We can get more high fidelity in the future. But anyway, so let's take one of these sim motors and drag it right up on here into motors. Okay, and let's rename that to, maybe we'll call it left primary motor. Okay, and looking at some of the parameters over here, I've just given it a max torque value of 100. I'm not quite sure whether that makes sense for sims or not. Again, this was more of a, let's get something working and then we can improve the fidelity later on. So we've got our left primary motor, and let's add, through copy and paste, let's add a left follower motor. All right, so now we have the left side motors, and if we select both of those and copy and paste, we can make our right side motors. All right, the motors are really easy. Okay. So now we've got our motors. All right, now that we've got our motors done, it's time to add some motor controllers. So down here I've got a Talon SRX motor controller. So let me drag this up onto here. All right, add it to our motors object. And I want to rename it. Now let's call this left primary motor controller. Okay, and let me copy that and make a left follower motor controller. Hopefully this is exactly how you do it on a bot, or what your bot design is. So now I've got a primary and a follower motor controller. Now I've got to do a little setup on these guys. Let's pick the left primary because that's got more setup to do than the follower. Okay, so on the primary side, we need to connect it through a WebSocket interface so it can talk to our code running on the RoboRio. All right, many of the parts that I have in the starter, I've already done that for because they're standard RoboRio parts, and I just went ahead and connected those so you didn't have to. But for Talons, not everybody's going to be using those. They're not standard parts of the RoboRio, so we're going to have to tie that together. Good news, it's just super easy. So with the left primary motor controller showing over here in the inspector, let's drag this WebSocket interface from our RoboRio and drop it right onto there. Now, that Talon motor controller, when we're running, will talk to the code, the server, and the running in the RoboRio. That'll all happen behind the scenes for you. You don't have to worry about all the technology, but this establishes communication and ties it together. Now, this next field is the ID of the motor controller. So this is the ID that you set up for your Talon. So let's give it the number 1 because our demo code that we're using has it set up that way. Now, what motor is it connected to? Well, that's easy. Let's drag in this left primary motor. All right, that's super easy. And Is there a follower motor controller? Well, in this case, since it's the primary, yes, there is. There's the left follower. So let me bring the left follower in there. And now, encoder. All right, well, we want our left side encoder, so let's just drag this guy right in here. Boom. Peasy. Easy peasy. So we're all set with that motor controller. And if we look at the follower, we've got similar steps, but not as many. So we need to connect it to our WebSocket interface. So let's drag that over here again. All right, we need to give it an ID, and I think the demo code has the follower at ID 10. And we need to give it a motor. So this will be the left follower motor. Drag that in there. There is no follower motor controller, and the encoder's on the primary, so we don't have to do anything here. So we're done. And we're going to do the same thing for the right-hand side. All right, so we can drag this up here, or you can copy and paste, whichever means you like. All right, so this will be the right primary motor controller. Okay, and I'm going to copy that, and I'm going to call this the right follower. Motor controller. And we'll go through the exercise we did a second ago, where we will give it a WebSocket interface. All right, the ID we're going to, for the primary, we're going to give as 2. We're going to drag in the right primary motor here. We're going to drag in the right follower motor controller here. We're going to drag the right encoder in here, and we're done. One thing I will mention, I didn't mention on the left-hand side, but this flag that says inverted, okay, that needs to match what you're doing in the robot code. So if you've said that in your robot code that the right motor is inverted, we're going to have to set that to inverted. If not, we leave it unchecked or false. We'll have to figure that out when we look at the robot code later on. But if we don't set this properly, the robot's not going to run. It's going to drive in circles or spin around in circles versus driving forward and backward and so on. So it's going to be a little weird. But anyway, we'll look at the demo code and see what that's supposed to be. So now our motors are done. So we've got motors, we've got motor controllers, we have wheels, and finally we need gearboxes to tie it all together. So let's come back here. I'm just going to shrink this down to give us a little more space. On our drive system, create a new, right-click, create empty, call it gearboxes. All right, now we've got a gearboxes area. So to make things easy for you, I've already got a couple of, or a gearbox prefab. So a dual input gearbox prefab, sort of like a Toughbox Mini or something like that, right? So I'm going to drag that on here. And now I'm going to rename it to be maybe, left gearbox. Okay. And we're going to edit that, right? We're going to connect it to motors and to wheels. So since it's a dual input gearbox, it's asking for, well, what two motors are connected here? So since this is our left side one, so let's go back into motors, and we're going to drag the left primary motor in here, and we're going to drag the left follower motor in there, and boom, we've connected our two motors to our gearbox. Much easier than those mechanical guys have it. This is super easy. Now, how many wheels do we have on the one side? So we've got 3 wheels. So let's put in 3 here. All right, and it automatically creates a list of 3 things for us to drag our wheels into. So let's open up our wheels, and this is the left side. And so let's put in the left front wheel and the left middle wheel and the left rear wheel. Now, to be honest with you, for what we're doing here, it doesn't matter what order you do these in, but I like to think, front, middle, rear. But now we have the gearbox on our left side done. All right, so let's drag another gearbox in there. All right, and be careful when you drop things down. They've got to be right on top of the game object that you want them inside. If you put it, just under or just above, it's going to go in the wrong place. If you've used Unity before, you're probably pretty aware of that kind of stuff. So we're going to call this the right gearbox. And same procedure, we're going to drag in our right motors. So we got the right primary motor, and we have the right follower motor, and we got 3 wheels on this side. And you can guess if you're going to do, if later on you're going to do one with 4 wheels, well, you're going to change that number 4 and have 4 wheels in here, or 2 wheels, you're going to change it to 2 and put 2 wheels in. So anyway, we need the wheels. So let's do, this is the right side. So we're going to do, I'll say right front, right middle, and right rear. Okay, gearboxes are done, and ready to go on to the next step. All right, we're almost done with our robot construction in Unity right now. One thing I'd like to do is add something to the robot that helps us identify the front and back. And what I want to do is I want to add a camera to the front of the robot, which will, again, help us figure out where the front is, but also give us an opportunity to see how cameras work, and we can do some visualization with those. So if you go down to your assets, down in FRC simulation, sensors, there is a camera object. So let's drag that up in here, right into our robot, right? And you can see it's put something on the screen, and it's got this little camera image, which I find makes it hard to see. So what I'm going to do is I'm going to scroll down a little bit, and you drill into there and select the camera itself. And there's this, you see this little eye, this visibility thing over here? I'm going to turn the visibility of that off. So now we've got an unobstructed view for our camera. Now over here, we've got the view that the camera is seeing. So it's actually, since it's 0, 0, 0, it's halfway under the floor, looking at looking up through it, and the other half can't see much because there's a robot over the top of its head. So we want to move it, right? So come over here. You got to be careful. You got to select the camera itself, not this camera game object, not this piece down here, but the camera game object, because there's multiple parts to this, and we want to move that, right? So that'll move our little rendering. I've just created a simple 2-inch by 2-inch by 2-inch cube, right? Not very fancy. You guys can get fancier later on if you want to download some mesh files from whoever makes your camera. I don't know if the folks that make Limelights have those, or the Intel RealSense folks I know have some, but you can make it prettier. But this is what I have right now. So now we've added a camera to the front of our bot. If I select that camera, you can see what it's seeing now. So it's got a view of the front of the arena, and nicely we can tell the front of our robot from the back of our robot. So when we're driving around, we've got that little bit of visual help. Okay, now it's time to work on the robot code side of this project. So some things you're going to need. All right, I think I've pointed this out already, but we're going to use one of the examples that come from Across the Road. All right, they've got a bunch of different examples here, and we're going to do one of the Java examples for differential drive. So make sure you've downloaded it and unpacked it and have that available on your computer. And the other thing is you're going to have to download the latest Talon drivers, right, or the Talon code with the vendor dependencies and so forth, and have that available as well. And I'll have a link in the YouTube description for that. So now that we have those, let's go to Visual Studio Code, create a new window, and let's open the folder with the differential drive example. So I'm going to go browse through my stuff. Now I'm using Linux here, but this is going to be pretty much the same on Mac or PC. It's really not different. So I'm going to go into this Phoenix examples thing that I've unpacked it to, and I'm going to Java General, and I'm going to go to this differential drive project, and I'm going to say OK and open that folder. And it opens, and we're prompted to update it. All right, so we do want to update it, so let's just say yes. Okay, yes, we will do a build afterwards. And that's coming in. Now, we're going to have to do a couple of other things as well. First, the examples were built before the latest, for the season's code from Across the Road came out. So we're going to have to update our vendor deps to point to the latest Phoenix JSON file. So you're going to have downloaded those, or downloaded that code, and you go to vendor deps, right? And we're going to drag this file over here on top and replace the one that's there. And all it does is it calls out the 519.4 version of everything versus I think the one that was there did the 519.1 or something like that. They've made some fixes that allow the simulation to work. So that's going to be important. The other thing we're going to need to do is come to our build.gradle file, and there is an area down here which talks about simulation. So by default, you're allowed to run the GUI simulation, and it gives you a simple, socket-based driver station interface, so that you can actually run the driver station with this as well. What we're going to do here is we're going to enable the WebSocket server implementation. So just comment that, and just bring that line back, all right, from comments. And now, since we changed that, it wants to, rework everything here, but we're going to let it do that, and then we're going to do a build to make sure that everything is okay. All right, build successful. Good news. Now let's take a quick look at the program that came from Across the Road. So if we go into source, Java, all right, main program is what it always is. The two interesting things, the robot program and physics sim. So your robot program is, in this case, very simple. All right, what it's going to do is it's going to create 4 different motor controllers. Okay, on the right side, IDs 2 and 20, which is what we put in our Unity simulation. On the left side, 1 and 10. It creates a new differential drive and has them tied into those motor controllers. Also creates a joystick interface so that we can do some driving. Let's see, a couple other things here so we can track faults that happen. Now for simulation init, it's going to use this thing called physics sim, which we'll look at in a minute, but it grabs an instance of that and adds the 4 talents to it. The front ones, the front primaries, the front the followers, and also set some other parameters here, which actually we don't need for Unity. These are like acceleration and velocity bound to sort of give a profile to the way the motor is going to operate. Unity takes care of all that for us. This flag here, sensor phase, actually tells us whether the encoder, the sign of the encoder values are flipped or not. So this is saying true here, so we'll want to check that in our Unity code at some point. So that's the simulation init. Simulation periodic, as the name implies, it gets called periodically, and it says run the simulation. Now in teleop mode, very simple here. It grabs the 2 joystick axes, right, for forward and for turning, which we're going to need for differential drive. It also grabs button number 1. So if you got your Logitech controller, it's that blue button with an X on it. I'm not sure what it is on the PlayStation controller, but you can figure that out. And it does a little bit of stuff here, to translate these into good values, and then it calls differential drive, and it asks it to run an arcade drive on that. And then the rest of this here is collecting some data and building some debug messages that if you're holding down button 1, it will print out for you. So you can see, it prints out, I think, what the inputs on the joystick are, what the outputs of the motor are, the encoder velocities, and so on. Again, another thing here, looks like in this case, in robot init, they've taken the right side and inverted them. Okay, so we'll have to make sure we follow up with that in Unity. Now, physics sim, and this is the only place we're going to have to make any changes to this at all. Physics sim, takes the what it does here. Let's look at the run method, because that's where all the good work is done. All right, it grabs this period value, which is basically the delta time since last time it ran, because it needs to figure what it's doing here is it's computing velocity, so it needs to know how much time has gone by. What's the change in encoder value over the change in time? That'll give you the velocity, right? So it grabs the output percentage, all right, and then does a bunch of calculations on that to simulate quadrature positions and velocities and effects on supply current and bus voltage. Now, our simulation in Unity does all this for us. Okay, there's no need to do anything that's over here. So what we're going to do is we're going to comment out these 4 lines of code so that it doesn't interfere with what we're doing in Unity. Okay, so we just commented those out. We can probably comment back here a little further because we're not really using much of this, but the key ones are these 4. All right, so let's save that and do a build. Make sure we didn't break anything. Okay, outstanding. And now we're going to run our robot code against our Unity simulation. So we just finished a build after changing these lines. And let's come over here and choose Simulate Robot Code on Desktop. And that's going to start up, and it's going to give us these choices. And we want to select the WebSocket server as the interface to simulation, and say OK. And now our robot code is running. Now let's come over here to Unity and hit Run, or hit Play. And now it's playing, and we've got a very simple interface here. We want to select Enable to enable our robot, and let's push the joystick forward. We're turning around in circles. So if you remember, I said that we had to make sure that our inverted flags are set to be consistent with our robot code. So let's fix that. So we'll stop our simulation here. We'll come back to our robot code and see what those are set to. So if we go back to the robot code, you can see that they've got the right side set to inverted, okay, and the left is not. So let's come back to Unity and we'll try to fix that. So let's see here, right side. So let's select inverted on both the primary and the follower. And hopefully you won't have to do this in the future. The CTRE guys are talking about maybe having the inverted inverted flag come out through the simulation interface so the simulation can adapt, but it doesn't work just yet. So I changed that value, and now I'm going to enable, and I'm going to push the joystick forward. And we're going backward. All right, if I pull the joystick the other way, all right, and we go forward. So we still have an issue with sign. So what we really need to do is we need to, the way our robot is constructed anyway, is we need to invert the left side and not the right side. All right, so we're going to invert the left side, and don't invert the right side. Okay, and if we come back to the robot code, all right, let's stop the robot code, and you can see the CTRE team, put these nice bright red comments in here saying we need to update this to be consistent with our robot. So let's do that. Let's make this one false. All right, and set this one to true. Okay, now I'll tell you, this right now doesn't really have an impact because the simulation isn't using these values, but in the future it will, and you do want this code to be consistent with your simulation, so I definitely recommend doing it. So let's save that. Let's build the code again because we made some changes. And let's simulate it again. Okay, using the WebSocket server, say OK. And we'll come back here to Unity and we'll press play. And with any luck at all, when we enable, we press forward on the joystick and we're going to move forward. And if we bring it backward, we're going to roll backward. And if I move the left joystick to the left, I turn left, and the right joystick to the right, I turn right. And there you go. You can drive your robot around. While we're here, I'll show you a couple other camera views. So I can do, so display number 1 has the driver station on it. Display number 2 is sort of a bird's eye view, so you can drive around and crash into power cells and have fun, right? Display number 3 is actually the camera we mounted to the front of the robot. So, as you're driving around, you can see what's what. All right, so that's your, sort of like your, the onboard camera for your robot. Display, I don't know if I have display 4 set up, nope, but I have display number 5, which is actually back behind in one of the driver station locations, and 6 I think is the middle location, and 7 is the other side. So if you're a driver, you can see what the field would look like if you're in your competition spot. But that's pretty much it. We can drive around, and mission accomplished. So I'll try to follow this video up with some others that are a little shorter, but show how we might be able to make a more realistic looking robot. How we can make for perhaps better looking wheels. All right. How you might create certain kinds of sensors, like for instance, the kit usually comes with I think an ultrasonic sensor. So how can we simulate that in Unity and tie it into through the analog sensors and put it on our bot and so forth, and how do we use that? So I'll let folks know through Chief Delphi that there's something else out there. So stay tuned. I hope this was helpful. Leave me some comments if you have questions, or you liked it or didn't like it. But anyway, kind of interested in the feedback. Thanks. Good luck this season.